Today we're going to be talking about atoms, isotopes, and ions in today's lesson. What is an atom? One of our elements that we know on the periodic table is known as helium. It may look like the sphere to you on the screen, but really on the inside of this helium, it is going to be made up of different particles. And this is a representation of what an atom looks like. And with this representation, we know within an atom we have our nucleus, which is the center of our atom, which is composed of neutrons and protons, where neutrons are neutral and protons are positively charged. And on the outside that orbits our specific system or are in orbitals, which we'll talk about in a later video, are electrons, which are negatively charged. The important things to know about this is that the heaviest parts of the atom are going to be the neutrons and the protons, where electrons are much, much lighter, and so they don't really contribute much to the weight of your atom. And atoms make up elements. Like I mentioned before, helium is on our periodic table in the top right corner under number 2. But an element is the basic building blocks of life, and what makes up elements are atoms. So atoms build up our elements. We will refer to the periodic table throughout all of the videos on chemistry, as it is important and gives us a lot of information about our specific atoms and compounds. It gives us a lot of information about our atoms, molecules, compounds, and elements. Kind of for the introduction for what is an atom, the important thing to understand is that the number of protons defined the element or defined the atom. So here, we have the same amount of protons and the same amount of electrons, but in the left atom, we have no neutrons, and in the right atom, we have a neutron. So on the left, one proton is actually equal to hydrogen, and this is due to the atomic number, or the number under the category in the periodic table is 1, and that corresponds to hydrogen. And actually the same thing is here on the right, where we have one proton, so this atom is actually an atom of hydrogen, but we have an extra neutron, and this is known as an isotope, where isotopes have differing number of neutrons that may occur within your atoms in your elements. We'll talk about this a little bit more later about what this means, but this will affect the weight of our specific atoms. This will affect our weight of our specific atoms. Isotopes contribute to the idea of isotopic abundance, where there might be a couple isotopes for a single element. Or in this case, in our table, we have 2 common isotopes for nitrogen, and they have differing masses due to that extra neutron. Or from nitrogen 14, we go to 14.003 AMU, or atomic mass units. And nitrogen 15, we go up to 15.001. The percent abundance in the right column is important because this tells you how much this actually occurs in nature. 99.6% of the time, if I pick out a nitrogen atom, it will be nitrogen 14. But 0.4% of the time, it will be nitrogen 15. In an element, the average or the weighted average of our specific masses will give us our molecular weight, where our molecular weight will be equal to the percent abundance multiplied our mass for each isotope, and then we add them up together. And so the molecular weight of nitrogen, or the average weight of nitrogen, is going to be 14.007 AMU. And this is talking about atomic mass units, or the average mass of an atom of nitrogen. This is the same number as molar mass, but just given in different units, talking about grams for every mole of nitrogen. So this is the idea of isotopic abundance, and talking about isotopes. Now, let's move on to ions. As we know, the protons define the element, so these are both hydrogen again as well. But we actually have an extra electron on the right side. And this will change up our system a little bit. We both know they have hydrogen, or we both know they are hydrogen, so we know H will be the chemical formula with this. But on the right side, we actually have an extra electron or negative charge. Since we have an extra negative charge, we have to indicate it in the top right corner by saying H minus, where there's an extra minus charge from an extra electron. So if you see a charge in the top right corner of your atom, most likely it has a differing amount of electrons from the number of protons. If it's not written in, your electrons will equal the number of protons, and if we combine all this with nuclear notation, we combine the atomic number, the mass number, and our chemical formula in this notation here. The atomic number is just the number of protons that define the element. So atomic number and Y in this case will always be linked together. If your atomic number is 1, Y will always be hydrogen. Your mass number on your top left corner is the number of protons plus the number of neutrons. This indicates how many heavy particles you have within your nucleus. And what is not written in here is the charge will be in the top right corner as we saw before with the H minus. But if we have a differing number of electrons, it'll be indicated above the Y on the right. Let's practice again with isotopic abundance one more time to actually see how a problem may occur. Element A has two isotopes, A45 and A47, where A45 with an atomic mass of 45.0 AMU has a 75% abundance, and A47 has a mass of 47 AMU. What is the average mass of element A? So here, instead of giving a table, it's giving us to a word problem, but the average mass of our element is going to be the weighted average of each isotope. So molecular weight, or our weighted average, is going to be 0.75 or 75% multiplied by the weight of that specific isotope, or 45 AMU, plus 0.25 times 47. And if you add those together, you end up getting an average mass of 45.5 AMU. So if you have a bulk amount of element A, the average weight of it is going to be 45.5 atomic mass units for every single atom of A. Now let's actually practice the nuclear notation here. We're going to be identifying the element given here. So what species has 10 protons, 11 neutrons, and 9 electrons? Let's give the nuclear notation for the species. So the first thing, and the easiest thing to understand, is that we have 10 protons. So that is our atomic number in the bottom left corner. In the bottom left corner, we have 10. So this is the number of protons that we have. And we know the mass number in the top left corner is the number of protons plus the number of neutrons. So in the top left will be 21. Now, for the last bit of information in the top right corner is that we actually have a differing amount of electrons and protons, where we actually have one less negative charge than a positive charge. So that means we're actually net positive 1, or plus in this case. So if you see a plus, it just means you have one less electron than the number of protons. And like I mentioned before, the atomic number will always be linked to the chemical formula of your atom. So 10 on the periodic table will represent neon. And so this is the nuclear notation for this specific species. It is a mass number of 21, atomic number 10 of neon, and it corresponds to a positively charged species. Please check out my channel at The Science Equation for more chemistry and math practice. And please like this video and please subscribe. Have a great day.